Okay, during this lesson, we're going to talk about the trends of these two different things. First one is going to be ionization energy. The second one is going to be electronegativity. Okay, so at the end of this lesson, you're going to be able to talk about what ionization energy is, what is the trend that deals with ionization energy with the periodic table, and the same thing for electronegativity when we get to that. Okay, so ionization energy. Ionization energy is, simply put, means it's the amount of energy required to take an electron off of an atom. Okay, so these are going to be our valence electrons, or our outermost electrons that we're going to be removing. Okay, so an example of this would be if I had something like lithium, okay, and I went from lithium to lithium plus one electron, meaning I took lithium's 2s1 electron away from it. So 2s1 is now gone. Okay. Now, we see this a lot in bonding, but right now I just want you to know that ionization energy means removing the outermost electron. So lithium has a specific amount of energy that is required to remove this 2s1 electron, and we'll talk about this here in a second. Okay. What are the two things that ionization energy depends on? Well, I bet you could probably start to think about what would it depend on. And the first thing that probably pops into your mind is, okay, well, how far away is the electron from the positively centered core? The further away the electron is from the protons probably means the easier it is going to be to remove that electron, and that's one of the things. So what is the distance of the electron and nucleus, because you have to remember we have that positively charged center with our protons, and, well, how many protons do I have? If I have lots of protons inside of my nucleus, it's probably going to be harder to remove the electrons because they're highly attracted to the positively centered core. Okay, so we're going to actually call this nuclear charge. Okay, so this is number of protons. So now we can start to talk about trends now that we know what ionization energy is. If I'm going down a group, okay, ionization energy is going to become smaller. Why? The atom is getting larger, which means the electrons are further away from the nucleus, which means it'll be easier to remove the electrons. Okay, so going down the group, ionization energy is going to decrease. Okay? This is because you're increasing the amount of energy levels. Okay, so if you look at my example here, removing this electron from lithium is going to be a lot harder than removing this electron from cesium. Why? Look at the distance between the protons and the electrons. Okay, if you think about it, if I was to take a magnet and hold them like this, as they get closer, what eventually happens? That eventually happens, right? Why? Because they can start to feel the attraction of each other and they're going to pull forward, okay? So cesium, the magnets are like this. Lithium, the magnets are like this, okay? So it's a lot easier to remove the electron. So going across a group, we're going to talk about, well, how many protons do I have now? Because if you remember from our previous lecture, the electrons are in the same energy level because we're talking about the same period, okay? So if the electrons are in the same energy level, the distance is the same. What's changing is the amount of protons. So if I have more protons, the electrons are more attracted, right? Like Mrs. Stoser is attracted to Jimmy Fallon. The electrons are more attracted to the protons, which means it's going to be harder to remove them, and it's going to require more energy, okay? So going across the group, ionization energy increases. Why? More protons, more attraction. okay? So I kind of have it says electrons are held more tightly because of more protons, therefore more ionization energy is required. Okay, last thing with ionization energy I'm going to talk about is first, second, and third ionization energy, okay? It's always going to require more energy to remove the second electron, the third electron, etc., okay? Meaning, second electron is going to be harder to remove than the first electron, and third electron is going to be harder to remove than the second electron, okay? So first ionization energy actually just means the energy required to remove the first electron and then second is energy required to remove second electron, and third is energy required to remove third electron. So first is less than second, second is less than third, okay? So that's ionization energy. So let's summarize ionization energy here. So we're gonna skip this part, okay? Summary. So if I think about the way my trend goes for size, it's an upright snowman and then it gets ninja kicked over, okay? Ionization energy is actually going to be an upside down snowman, right? So going down the group, ionization energy decreases. Why? Exactly for the reason why the atom gets bigger, right? So if the atom is getting bigger, ionization energy must be going down because the electron is further away from the nucleus and it'll be easier to remove. We're going across a period, ionization energy is going to increase. Why? More attraction. If there's more attraction from the electrons to the positively centered core, it's going to be harder to remove them. Okay? So that's ionization energy. Let's talk about electronegativity, okay? So I'm actually skipping down to, this is page 93. Actually, you don't have any notes here, so let's kind of go rogue here. So let's talk about electronegativity. Okay. Now, ionization energy dealt with an atom removing an electron from an atom. Electronegativity deals with bonds, okay? So electronegativity is how much does an atom want the electrons while bonded to another atom, okay? So let me write that down for you. So electronegativity is the tendency for an element to attract electrons when chemically combined with another element, okay? So I know that oxygen, so this is a water molecule, right? H2O, okay? I know that oxygen has a higher electronegativity than hydrogen, and I'll explain why here in a second. But oxygen is actually going to pull the electrons a lot closer to him than hydrogen will, because oxygen has more protons inside of its nucleus, which means it wants the electrons more, okay? So I would actually have more of a negatively charged region up here because the electrons would be closer to oxygen than they would be to hydrogen, okay? So our trend here is actually going to be the same exact trend that we're going to have for ionization energy and for the same exact reason, okay? So electronegativity is going to decrease going down because electrons are less attracted to the nucleus. Why? Because they're really far away from the nucleus because we are dealing with really big atoms, okay? Our period trend going across a period, electronegativity increases. Why? Because the electrons are more attracted to the nucleus because there are more protons per atom, okay? So if I go back to my ionization energy trend, I can just go ahead and put ionization energy and electronegativity because the trend is the same, okay? So that is it for that. Oh, one more thing with electronegativity. Electronegativity, if I look at the periodic table that you guys use on your test has electronegativities on them, okay? You'll notice Noble gases don't have electronegativities. Why? Because they don't bond with anything, okay? This number right here tells me the electronegativity. So fluorine is actually the highest electronegative atom with a 4 electronegativity, where everybody else is smaller. So like oxygen is 3.5, chlorine is 3, sulfur is 2.5, etc. Okay? So that's it for this lecture. There is going to be a form for it, and I'll post that with the Blackboard link. Thank you.